cool. You can actually get out in less than 10 minutes.
Yeah, exactly. This is 579. So obviously you guys know that the parking garage is just right around the corner, so I'm sure you guys parked who knows where. So sorry about that for today, but
What building is this?
51.
Oh yeah, Area 50.
Yes, exactly. The area is all right, so is everybody cool with this switch? It is a switch to the class site. Yes? Yep. Okay, good. Perfect. All right.
Hey Jeff, is this one of your books?
Yeah, that'll work. That's
okay.
Yeah. So there's the Student Solutions Manual. They of course have it in the bookstore, but you can find it other places for this book, right? So if you want the Student Solutions Manual, they show you the worked out solutions to the
They break it down.
odd problems. Yeah. Cool. And anytime you guys have homework to turn in, you can just put it up here on the desk at the beginning of class. If you got it, you can just put it up here at the end of class today. Somewhere. All right, guys. So, before we get into any new stuff, any other questions from chapter 1 or 2.1? Yeah.
GFX, when it says GX and FX and all that letters,
Yes.
it all means the same thing?
They mean the same. They have the same idea,
Yeah.
but they allow us to define separate functions, right? So you have the F function, the G function, maybe the H
Yeah.
function. Yeah. So if they say, like, for example,
Yeah.
right, they say this kind of weirdness. Then I can refer to all three of these separately. I could say, for example, what's H of 5? So where would you put that 5? Yeah, so you put it right there. Wherever you see an X in the H of X, you would replace it with 5. So replace the X with 5. I better replace the X with 5. And that one comes out nice, right? How are we doing there? Are we cool with that? So that would be 10 over 1, so just 10. What about this? So I mean, obviously I got to do G of 3 and F of -1 is the same idea. You just replace the X in those functions with the number I put in there. It's just substitution. So what about this? G of W. Nothing major. Nothing major. What do we replace X with?
5.
5. Here I want to replace X with. All right. So what would it be? Yeah. Replace X with W. Now I know right now, and this is good. If you're asking yourself, why the hell would you ever want to do that kind of weirdness? I appreciate it. But this is because later we're going to be doing stuff like plugging in W minus 2. So we actually shift that whole function over 2. You know, we have to be able to plug other variables in. Like, I don't like the variable X. Well, you're allowed to replace it with W. That's one level. That's kind of like a lane level. But I can also replace it with A plus 3, X plus H, which becomes big in later math courses. You have to be able to plug variable expressions in. And it's just the same damn thing. You just replace the X with whatever the hell's in there. It's almost too simple, I think. People don't trust it and say, no, it's more than that, and you overblow it. Yeah. Is that cool?
Yep.
Yeah. What point do we know that H goes through? What point does the H function go through if I were to plot it? 5, 10, right? A point has two pieces to it, of course, right? So this goes to the point 5, 10. An input of 5 has an output of 10. Is that cool? And of course, this is a function. I've used function notation, so I'm saying it's a function. What does that mean about it? For every input, There's only one output. So when I plug a 5 in, I can't get more than 10. And of course, looking at the work, of course you can't get more than 10. How the hell are you going to get something else than 10 in there? Unless you do it wrong. Right? So doing it correctly, I can only get one number out. There you go. That's even a more direct mathematical reasoning as to the definition of function. You can only get one number out when you put one number in. Cool. All right. So any other specific questions from?
Yeah, the chapter 1 review, number 66.
Oh yeah. 66 gave us trouble in both parts of that. Let's see. Oh, 66, good. This is the part people hit and they hate because there's no numbers.
Yeah.
All right, well now, take a second. Do you guys see, so this is the question, P equals M divided by S, solve for M. Now look at this little analogous problem. If I had 10 equals M over 4, how would you solve that? Multiply both sides by 4, right? How do you know to do that? Because right now it's dividing. I want to kill it. I do the opposite operation, right? There's a lot of violence in my math, but I'm so if I multiply both sides by 4, it dies. What I always get on this kind of problem is somebody gives me like M equals S over P. They just throw something at me. I'm not sure how that went there. It can't, right? Considering what we just did there. And that, our brains attack that a lot easier because there's numbers in there. We're like, okay, there's numbers in there. But here's the same stupid thing. I want M by itself. What's happening to M? Why is it not by itself? Being divided by S. How do you kill the S then? Opposite operation. Yeah. So M equals SP or PS, whichever way you want to do it, right? Commutativity of multiplication. I can turn those around. Is that cool? Yeah.
So if the M was on the bottom, you do the same thing. You can't just multiply the M.
Now here, if I like that question. If the M were on the bottom, this one's done. So let's do another example. What if I needed to solve for M, but the M was on the bottom? And that one's a little bit more evil, right? Because the variable I want to solve for, why does it suck where it is? Because it's on the frickin' bottom. When variables are on the bottom, it sucks. So how do I take care of that? It sucks that it's on the bottom. So I multiply by M, get that thing out, right? So whenever the variable I'm trying to solve for is on the bottom, the first damn thing I do, just about most of the time, is I multiply by it to get it up. So I can't do shit with it when it's down there. I can't get at it. So on this side it cancels. Now it's up here. How do I solve for M? Divide by P, right? So once you get the ugly part taken care of, it's easy after that. Divide by P. So in this case, M would equal S over P. What I think I had up here before, I had a little ESP going on, but I wasn't. You guys see that? So these are two different problems, right? This is a problem from the homework, and this is a side problem. I like that question, though. It's always worse when the variable's on the bottom, but that's not that bad. Let me do one more example, like solving for a letter. Solve for C. So what's the first thing you think you should do? Let me see if this thing's working over here. Yeah, you can see it. Whoa. You guys still see it? Yeah. All right, what do you guys think? What's the first thing you want to take care of? That's the ugliest part of the problem. Exactly. Identify. I hate that stupid L on the bottom. Let's make it a big old fraction. I can't even get at my C because it's all, everything's stuck over the L. So kill the L. Multiply both sides by L. Now sometimes what I have is people will write L here as if that L multiplied, but that L died. Or canceled, if you want to be more gentle with your math. right? So be careful. It canceled. So let it go away. It's gone. Now how to get C by itself? I want to get rid of what now?
Minus the
Beautiful, right? You identify where your variable is. It's in this part, this term, and you get rid of the other terms. Minus W, minus A. And this freaks people out too. What is LD minus W minus A? It's LD minus W minus A. I don't know. Right? Well, in the last step here, maybe there's one more step after. Something like that. Divide by -2. I like it. You see how it's almost always division is the last step, right? Now you could bring the negative up and change all the signs, but you know, same thing either way, right? So C would equal LD minus W minus A over -2. Craziness. All right, I know I said one more, but I'm going to do one more. Because this one is, that one was just totally made up. I have no idea what the hell D is in W. Anybody know what this, anybody know what this function is? Yes, beautiful. If you know the Celsius, you can convert to Fahrenheit. We're in this country one of 3 on the face of the earth, I think, that doesn't use metric, which means we don't use Celsius. So we normally know the Fahrenheit. Maybe we want to convert back to Celsius. This formula is not good for that, is it? This formula is good for when I know C and I don't know F. So how do I make a formula that's good for when I know F and I don't know C? I have to get C by itself, right? So what's the first thing you do there to get C by itself? Where's the C? It's in this term?
Yeah,
So you want to get rid of the other terms
minus
first.
32.
You guys see that? You almost always divide, or you know, you want to get the variable with the coefficient maybe by itself first, and then kill the coefficient. Because if I multiply by 5/9 now, I have to multiply everything by 5/9, and I bring in these unnecessary fractions, right? That's why you almost always divide last, so that's the only place you'll bring fractions in maybe. And then you're done, who cares? So what I get here, I get F minus 32 equals, now I kind of gave it away just a minute ago, but what do you do to kill this thing here?
5/9.
Beautiful. Because to kill the 5, I've got to multiply by 5. To kill the 9, I've got to divide by 9, so I just go ahead and multiply by 5/8. Get it all done at once, right? Multiply by the reciprocal. Bam, bam. So C equals 5/9 F minus 32, right? So today it's supposed to be like 83 or something here, right? So can you guys figure out what is that in Celsius? It's going to be 83 degrees here Fahrenheit. What is that in Celsius? Figure that out.
So when you do on the second part where you put 5/9, so you wouldn't say 5/9 times C also? You only do it to the 9/9.
It's sort of like this. No, watch. It's exactly like this here. What is 2 times 4 times 5? How would you guys do that? 8 times 5, which is 40. Now, if somebody said 2 times 4 times 5 is 8 times 10. Do you guys see where that came from? They did 2 times 4 and 2 times 5. How many 2's do I have up there? So they can't both get 1, right? So this 5/9, it died right there. Is there 5/9 left for the C? No, it died.
So it's not distributed properly.
Not a cross multiplication, right?
Okay.
If it was, see, these are all multiplying. The 5 does get multiplied by the 2 because the 2 is in the 8. Do you see that? If it was 2 times 4 plus 5,
Okay.
of course I would do 4 plus 5 normally, but you could do this also, right? Because multiplication does not play well with addition. That's why it's got to do this funkiness, right?
Okay.
Multiplication plays really well with itself. That came out wrong. Don't judge multiplication. So that's why that works directly. This, I've got to have this little sideways twist thing here because multiplication and addition don't play well with each other. So who's got the answer here? If the Fahrenheit is 83,
It's 51.
good, that'll be 51 in there, right? Order operations got to do in here first. So 5/9 times 51.
I just don't know how to convert.
9 goes into 51 just under 6 times, so 27 maybe.
28.
Say again, sir? 28 and a third.
How do you,
Let me see, 9, 6, yeah, that sounds about right. So if it's 28 and a third degrees Celsius in Canada, that means it is 83 degrees Fahrenheit here. They're both the same anyway, but how are we doing? Yeah.
What's that number to the left? Yeah, what is that number?
5 9's 51?
51.
Yeah. 51. All right, cool. Any other questions from the chapter 1 or section 2-1? Don't forget what's happening tomorrow. I always get attention when I do that. What is happening tomorrow? Quiz, right? Quiz on chapter 1.
And we're going to have a review today?
That's what this really is right now, so that's why. If you have any questions from chapter 1, this is the time to get them out there, right? So I think chapter 1 had a couple of word problems in there, so I'm surprised I haven't heard any questions on that yet.
72.
There we go.
I've never heard that before. Oh, let me point this out real quick. In the very back of the book, there's geometry formulas. On the back page, there's geometry formulas. 72 is not really a word problem quite. It's let's see, a sheet of plastic shrink wrap has a thickness of 0.00015 millimeters. Alright. And the sheet is 1.2 meters by 79 meters. Holy crap and a half. Use scientific notation to find the volume. Ooh, I like it. Now, what's the major problem with this problem, the way it's given to us? The units don't match up, right? Does anyone know millimeters are how many meters, or how many millimeters does it take to make a meter?
1,000.
1,000. Cool. So, which unit do you want to convert to? Do you want to convert everything to millimeters, or do you want to convert that to meters? Now, here's the thing. This is a little side note. This is nothing you normally learn, which is unfortunate, but how many metric units do you guys know? Like, what's the largest one we normally use in everyday life to go between cities, maybe? What's the largest unit of kilometer, right? There's a kilometer. Normally, we don't know the next two. Then there's a meter. We don't normally know this one. Then there's a centimeter, and of course the millimeter. Right? Centi, it takes 100 of these to make one of these, 1,000 of these to make one of these. So it's going to take 10 of these to make one of these, and so forth. That's why metric is so beautiful, because our number system is based on 10. Most likely because we have 10 fingers. If we had 8 fingers, we'd have a base 8 number system. That'd be freaky. This one is actually called a, anybody know what this one's called? Good, decimeter. That's like decimal, the first decimal place, like a whole meter. This would be the first one that's a part of a meter. This one is kind of like that guy's big brother. Decameter. I love it. I always remember that this is the bigger one because damn, it's big. Right? And then this one is another weird one. Hectometer, yeah. So we have hectares. We use hectares to measure, sometimes to measure land area. Yes, and that comes from hectometer. So here's the funny thing. Here's the stupid thing about metric. This is silly. To convert from millimeters to meters, you would move the decimal 1, 2, 3 times that way. Since it's based on 10, it should be easy as hell to convert. And it is. Every step you take is a step of 10. That's silly. So if I have 0.00015 millimeters, I've got to move the decimal 1, 2, 3 times that way, because that's the way I'm going. Isn't that silly? So it's already small, but it's a small number of millimeters. So how many meters is going to be? A crazy small number of millimeters. I mean, how many more zeros in front? 3. So it'll be 0.0000015 meters. Now the problem says use scientific notation, and now you see why, because I got this crazy small ass number here. So how would that number look in scientific notation?
1.5 times 10.
Yeah, you got to do 1, 2, 3, 4, 5, 6, 7. So 1.5 times 10 to the negative 7 because it was small. I like it. Meters. So how do you get the volume of something in this shape? Yeah, length times width times height to get the volume of something rectangular like that, right? So the volume here would be length, width, height. I think that's one of the ones they give you back here. They should, yeah. So volume is 79 meters times 1.2 meters. Oops, what's 79? I got to put everything in scientific notation, my bad. 79 in scientific notation would be, yeah, you just got to move it once. So 7.9 times 10 to the first. 1.2 is already there. 10 to the 0, which is weird, so I'll just leave it at 1.2. And that guy is 1.5, 10 to the negative 7. Okay. And now you just have to do 7.9 times 1.2 times 1.5. You do that in calculator, it's fine. What do you get there? Like 14.1. Anywhere nearby?
14.2.
I gotta. That's all I can do, guys. I have to show that off. Times 10 to the what? Good. So you got 1 10 there, no 10s there, negative 7. So 1 minus 7 is negative 6, right? You just use exponent properties on the 10s. Now, yeah.
Do we have to do exponents all the way through, or can we just wait till the end to do?
You can just wait till the end. I kind of collect all my 10s to one side. That's a good idea. And then just attack it with rules of exponents. Yeah. What's kind of wrong with that answer? I think they say.
Because you have to move it over.
Exactly. Why is this not scientific notation? Where should that decimal be? Yeah, it has to have a single digit because the 14 has a 10 in it still, right? 14 has got a 10. Scientific notation sucks the 10s out of something, right? That's what it does. So there's still a 10 to suck out of there. So here's probably the most direct way to do this. How do you write 14.2 itself? Let me just bring this down. This piece is okay, right? How do I write this in scientific notation?
1.2
times 10 to the 1. And then you just put these together, right? That's a good way to do it. Me, personally, what I do is I say, he wants to move it back 6. If I move it back 1, now he only has to go back 5. See, but that's what you would get there anyway, right? So either you can talk it out, or you can just do the math. Either way, you'll get there. 1.42, 1 minus 6. What's the units on this? Meters. Cubic.
because we converted.
Because there's a meter, meter, meter. Meter times meter times meter is meter cubed. Right? Volume is always cubic because it's 3-dimensional. Cool. Area is always squared, so forth. That was an ugly problem. That definitely was. It had a lot of steps to it. So let's go back a step though, and let's do one of the. Did everybody do the word problems okay? Which would be awesome if that was true. 68, 69, 70, 71.
Can we do 71?
Oh, 71 is actually not a word problem.
The volume.
Let's see, volume. Alright. Alright, we'll do 71, then we'll look at a couple of word problems. For a cylinder. By the way, just to let you guys know, we will every day we'll take a break at some point. Right? So I'll kind of try to feel you guys out as to when a good time to take a break is. Obviously, a little too early right now, but just so you know, you have a break coming up eventually. Here's a cylinder, right? So a film canister. The radius is 1.5 centimeters. And the height, and the, what did they tell me? The volume is 28.26 cubic centimeters. Determine the height, h. And they say use 3.14 for pi. We all know that that's not what pi is, but it's just an approximation. Okay. So first thing we need, obviously, is the formula for the volume of a film canister, a cylinder. And here's the cool thing about this. What's the area of the base? The base, of course, on this is a circle. What's the area of the base? Pi r squared. Right? And at some point, if I want to take some time, I can show you proof as to why that's true. It's a really cool proof. But And here's the funny thing. Think about this. This is like a stack of a bunch of circles, right? So the volume will be,
The area times the height.
I love it. It's always the area of the base times the height for a repeated shape. Because they got like this many circles. So it's going to be this many of these. So it's pi r squared times h. Now that you've got the formula, of course it's back in the back of the book also. You don't have to come up with it yourself. Now that you've got the formula, it's just a plug and chug. They tell you v, they tell you r, they tell you what you use for pi, solve for h, right? So it's a really nice problem now. It's just a plug and chug problem. Is that cool? So here would go,
Well, you want to get H by itself.
you don't have to solve for h first if you don't want to, that's fine. Yeah. So 28, if you do though, that would be nice. And it's here. Because you want to, and solve for h, you can solve for h now or solve for it later. 3.14 for pi, r was 1.5 squared, and now you do this and then divide and you get your h, right? Not a problem. The big deal there was realizing that you're not on your own for these formulas. They are in the back of the book. Because if you don't have a book yet, you can Google the bad boy. So, right? Or Bing, whatever the hell you use. Not Canister. So let's do a couple word problems real quick. We'll get back into chapter 2. I want to try to finish chapter 2 today. We'll see if that comes true. Yeah.
I didn't have a problem with question 69 on the.
Okay, cool. Or not cool,
It's a
but
word problem.
understood. You had a problem? Yeah. What's the one I just did? Yeah, this one.
I love this.
Oh, remember up here the kilometers, hectometers, decameters? King Henry died Monday drinking chocolate milk. That's a mnemonic device to remember that. Because you remember how to write it, then you just step to convert. It's silly. Metric is stupid easy. America will never go that way because we're too entrenched in units that were based on the measurements of the King of England. That's what our system is based on. How long was his foot? Well, that's a freaking foot. Yay. I thought we had a revolution, but who knows? It's kind of silly. All right, so I'm going to look at number 69 on page 97. I like it. All right. Here is my, well, this is not just mine, but whenever you have a word problem, and do you know how I looked at number 71, I looked at number 72, and I said, that's not a word problem. But if you just glance at it, 71 looks just like 70. I mean, they have the same number of words. But 71 is a plug and chug problem. I have a known equation. 69, I have to make my own equation. That's the problems that are word problems. Those are the hard problems. Because I don't have a formula I can use, I got to make my own. Shit. So the first step in a word problem is not mathematical at all. It's just, don't look at the 19 less, don't look at the 115, don't look at any of the crap. Just say, how many things are involved in this problem? How many players are there?
2.
2. What are they?
115 and
No,
19.
careful.
No, we got A and B.
Oh.
Be more specific.
A and X?
Use the same language the problem does, so you never lose track of what's what. So I have
A number
a
that's
number,
less than 19.
yeah, and another number, right? Or a smaller number even. So I have a
19
number.
less than the other number.
X minus 19?
You can spell number. A number. No, you're getting ahead of me still. And another number.
Excellent. Which means
So trust me, so if you had like Fred and Bill and Harvey and they make so much money and Harvey makes twice as much as Fred and blah, 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 and if they all make $1,000 together, then the very first step would be Fred's salary, Harvey's salary, and whoever the last guy was salary, right? The first step is not math. It's just who's involved. What's their English name? We're going to give them math names now, right? Which one of these, the next important step is, which one is just X?
A number.
A number.
So a number is 19 less than another number. Which one do you have to know first to figure out the other one?
Another number.
Another number. So if I knew this guy was X, a number is 19 less than that.
So it's X minus 19.
There you go. So first step, English. Second step, what's just X? Third step, build everybody else, right? It almost always depended on somebody else. So like they say, the largest side of a triangle is 20 more than the small. Well, the smallest is going to be x. Large will be x plus 20, and so forth, right? You've got to find out what's just x so you can build on it. A lot of people do this. They don't do any of that crap. They just say x minus 19 equals 150. Yay! Right? I'm sure I don't want to make you feel bad if that's what you did, but do you see now why that's wrong? How many numbers are here? 1. X minus 19 is one number. And they say the sum of two. Now I need two numbers to add. And this just represents one number. It by itself is 115? No. Right? So how do I get now, what's the equation now?
You gotta do x plus y equals 115, then you gotta plug that in.
Gotcha. If you want to use two variables, you can. You don't have to, but you can certainly use two variables. I'm not saying you can't. It's beautiful. I love it. And then I just solved that. Getting here is the hard part. Solving this better be the easy part, right?
It says a number and then another number. Why wouldn't you use x and y? Since they're
You could.
Oh.
The reason I don't is because using x and y will work.
I just like substitution, you know?
I love it.
Yeah.
It'll work because then you look at it like you have two pieces of information for the two things you don't know. I love it.
Okay.
Personally, putting a y there sort of makes it seem like it could be whatever it wants to be. It can't. It's got to be 19 less than this other guy.
Oh.
So if you'd rather do this problem like this, here's a whole other way. Or you can say a number is y.
Sorry, I didn't.
No, you're good. I love it. Another one's x. So then x plus y equals 115. But what's y? It's got to equal x minus 19. So you plug that in and you get the same place. Yeah. Either way is good.
It's actually an extra step.
Yeah, it's an extra step, but it's a little bit easier to kind of put it together maybe. I like this way personally. That doesn't mean I'm going to hate you if you do that way. I mean, that's beautiful. I love it. Either way, it's beautiful as long as you get to the right place and you show me what's going on in between. I'm happy. Okay. Cool. Maybe. Some of you look very concerned. How are we doing? Is that semi-decent? All right.
We're not gonna have more problems with this.
Whatever's in chapter 1
Oh, okay.
could show up on that quiz, yes.
Is it a long quiz?
I don't know. I haven't made it yet.
Oh.
See, I don't make it until the day of, so then I can, the questions like that, I'm like, I don't know, I'll find out. No, but normally my quizzes just let you know they're either like 4 or 5 problems long.
Oh.
They're right to the point, very nuts and bolts. So we'll make sure everybody's got the basics, right? Yeah.
I know you said this should be the easy part, but
Oh, sorry.
if you
Let's
solve
solve it.
19, isn't that adding more than you should? Shouldn't it be minus 19? That's the way I'm thinking, because you're trying to find the sum of 2, and one of them is 19 more than the other. So
Is it 19 more or 19 less?
Well, right. So maybe I'm just saying it backwards.
This equation is true, right? Based on what they told me?
Right.
So now you let go of what got you here. You look at this like this is where you start now. If you solve this for x, you'll know what this number is, and then you subtract 19 from it to get the other number.
Go backwards.
You don't have to kind of keep that in your mind as you know. You set this up based on truths that they've told me. I can then look at this by itself and solve it. Right? So how do I solve this? Like you said, I can add 19, put those together. Divide by 2, yeah. So what do you get there? 8.
And then subtract later. Plug it in.
Yeah, so now you can go back up. Here's the last thing about this. If you do this, it'll help you set the equation up. It'll help you answer the question. Because if you stop there, you're not right. You're partially right.
Now you plug in 67.
Yeah, this is 67. Box that off. This is 67 minus 19, which is 48.
And that would be the small one.
So there you go. Right? A lot of you guys are going to skip this step. You have increased your probability that you're going to make a mistake here. Right? So trust me, it's not just me that you should do this for yourself. Keep yourself straight. Let's try number 70. You guys take a minute. Try to do number 70 unless you've already done it, or maybe redo it if you think you might have done it wrong. Let's just all start on the right foot. In number 70, how many things are involved? Oh, sorry.
To the 69. When you say a number or another number, the origin is a number. The origin is a number, not another number. That means when we get x equals 67, that's a number.
That's the number.
That's a number.
Good.
Because the number is x minus 19.
Yes.
Right.
And again, the reason I do this is I want to use exactly the words that the problem used, so that it's easy for me to check. If I come back, if I did this the other way around and I came back and read the problem, I'm like, what the hell did I do? I got it backwards.
It means that the number is 67 and another number is 8.
Using exactly their words? No. Because they say a number is 19 less than another one. So which one of these is the smaller number? That one. So that would be a number. Right? I think this problem actually said the smaller one, so that's the one.
At the end it says, what is the number?
What is the smaller number, right?
Yes.
Find the smaller number. Yeah, that would be the 48. Cool. I like it. But I understand what you mean. These kind of sometimes are going to sound a little weird, but I'm going to use exactly the language the problem does so I can see the connection. So I don't want to use necessarily A, B, C or something, because then I lose the connection with the problem. Right? Okay, maybe. Okay. So here's a good example, number 70. Can somebody tell me what the players are in number 70? What do I want to write in English here?
3 different angles.
All right, what are they?
A plus B plus.
No, come on now. What are the, I don't want any math. Pure English. I got one angle. Let me catch up to you, sir. One angle, second angle, and third angle. I love it. And you know from experience that sometimes this will say like one angle, larger angle, middle angle, or something, right? Use exactly the same. Trust me. You don't have to. It'll get more confusing if you don't. Right? But use exactly the same language they do. And then you can make the connection. Which one of these is going to be X?
The second angle.
I love it. Do you guys see why? One angle measures 3 times the second. The third angle measures twice the second. So everything depends on the second. I got to know that first. So if I call him X, what can I call this dude?
3x.
Yeah, one angle is 3 times that. The third angle is
2
2 times that. So this is relatively easy. This is not like 7 more than 4 times that or something, right?
Now you plug in the numbers.
Now here's the thing.
Okay.
Angles of any triangle must do what?
Equal
180.
You gotta remember that, because they don't tell you. It's like they don't tell me enough. They don't have to tell you. Every triangle, if you add up the angles, has got to equal 180. 180. Yeah,
So
right?
3x plus x.
Because real quick, all these angles are what? And they add up to be 360. Triangle is half of that. 180. So all the angles in a triangle. So this angle plus this angle plus this angle equals 180. The mistake I see all the time, and you guys see why, this is a mistake. I see this. 3x plus 2x equals 180. Because they focus on the 3 times and the 2 times, they don't realize they're losing the dude that everything's built on. You don't have all 3 angles, you only have 2 angles. That's no good. You're going to get funky answers, possibly, right? So now should be the easy step.
Put them all together and you get
Yeah,
180.
6x equals 180, divide by 6. 30. So then you come back, x is 30 degrees.
90 and 60.
90.
Yeah, so this will be 90 degrees,
What's the name of this triangle?
60 degrees. 30, 60, 90.
There's a name for that triangle.
Yeah, actually it's the 30, 60, 90 triangle.
Oh, yeah, that's
Yeah. Sorry.
It's it.
And they kind of double check. Do they do what they're supposed to do? 30 plus 60 plus 90 is 180. Sweet. You can always check at the end. Make sure they do what they're supposed to do.
Good call.
I like that. Alright, so we're going to, obviously there's a section coming up here soon that's going to have a few more little advanced word problems. We haven't seen percentage word problems yet. They're coming. Right, some more advanced geometry, word problems, stuff like that. So throughout this course, there are going to be word problems every now and again. And I'm trying desperately to get you guys to not be so averse to them. They're not that evil. Yeah. They are evil, just not that evil. Okay. Any other questions before we get back into chapter 2? Okay, here we go. So last time we did 2-1. And we basically finished that bad boy. Oh, today, shoot, I forgot to bring Oh, I was going to bring the extra calculators, but I don't think we quite need them yet. So let's do this. Quick little review here. Which are functions?
First one and the third one.
Okay, gotta get a shot of you guys. Woo. Yeah, I know. Whatever works, right? I don't want to spend money if I don't need to. Because I don't have it. All right. Yes.
On testing quizzes, are we allowed to use a calculator or no?
Yes. You just have to show me the work. So, I mean, I will be showing you how to do several things in a calculator, like finding intersections of two things or whatever, but I will either say do it in the calculator so you don't have to show me any work, or I will say solve this, which means if you do it in the calculator, you're just checking the work you did. I need to see the work yet. All right, which one? Any of these functions?
First one. The first one.
So why is the second one not a function? Because of 0, I like it, right? And that is a 0 there. So 0 goes to more than one thing. I don't care that several go to 9. That's okay, right? Like the book that doesn't move. It's always 3 feet off the ground, so it's going to 3 all the time. The problem is that 0 seconds somehow is at 4 feet up and 2 feet up. What? I'm not sure what that means. Some kind of portal thing, I guess, maybe. What about the third one? Why is that not a function?
Vertical line test.
Vertical line test. You got at least one x that goes to more than one y, right? At any point that it kind of turns back on itself, that's no good. Okay. Now, why is the first one okay? Yeah, 1 only goes to 2, 4 only goes to 2, 7 only goes to 2. I love it. So this is a function, those two are not. I like it. And we already earlier did several function problems where you just plug and chug. So that's really all chapter 2, section 2.1 is, right? Yeah, so any questions over 2.1? We're gonna, good. Let's get into 2.2. Oh, yeah. No questions.
It's just another question.
So now 2.2 is where we start graphing these things. And let me just see what you guys know already. We did several the other day with the XY table. And you only have to do that if I say graph with an XY table, or if I give you a funky function that you don't know what it looks like. You just got to start plugging points in, right, to investigate it. If I just said graph y equals 4/5 x minus 3, what is the quickest way to graph it? What do you know about that line just because of the way it's written? What do you know about that line already?
Straight line.
Okay, I like it. It's a straight line.
Crosses through negative 3 on the y.
We know it's a straight line. Good, I like it. The Y-intercept. Now, I will be a little bit anal here. I'm normally not too anal, but the Y-intercept is a point. So what point is the Y-intercept? Careful. 0, negative 3. And of course that makes sense. How do you find the Y-intercept? You make x 0. How do you find the X-intercept? Make y 0. That's true for no matter what level of math. Me, my equations had 26 letters. If I wanted a W-intercept, I set all the freaking other letters to 0. It works throughout all math. So of course, whenever I make x 0, whatever's left is there. That's why that's always the y-intercept. I like it. What else do I know about this line? Slope. Yeah, 4/5, right? Let me see if you guys get this. If x is 0, y is -3, right? If I increase x by 5, if I make x go to 5, 5 and 5 canceled, so now y is 4 minus 3, so y goes up 4. So for every 5 that x increases, y will increase by 4. I call this like the amplifier. Whatever x is, makes y become 4/5 that. I'm trying to explain why that's the slope. If you don't quite get that, that's the slope. And what does the slope tell me? What's the saying? What's the, in English? Rise or run. I like it. So if it's ever anything negative, that would either fall or go back, right? So this is, I would go, where would I start if I wanted to graph this thing? What would I do first?
Down 3 on the y-intercept.
I love it. You got to start at a point on the line. What I always think about the slope is, it's kind of like you're going hiking, and this is the guy that gets you back to the trail if you go off the trail. So it says, okay, you start on the trail, 0, -3. And let's say you go off the trail, you say you go 5, you run 5, right? To get back to the trail, you got to rise 4. That'll get you back to the trail. Do you see that? So like saying go over 5 blocks and up 4 blocks to get to my house. Same idea. So if you go up 4, 1, 2, 3, 4, run 5, there's the other point. I like it. Cool. That should be decent. Right? Normally in Math 90, the big things that people hate are word problems, graphing, and factoring. Right? I'm hoping, yeah, the factoring I know is still a trouble. But normally once you get through some of the graphing, this level of graphing should not be bad. I'm hoping that's true. Yes?
How did you get the 0 on the y?
Y-intercept always has a 0 here, right? Because to hit the y-axis, I have to have not gone anywhere on the x-axis. X has got to be 0 for me to stay on the y-axis. Okay, cool. So let me give you a couple of related problems. How would you then graph something like this here? There's 2 answers to this question here. Let me make this big. How would you graph this? 2 answers. One of them is not plug it into the calculator.
Plug in 0 for one of them.
I like it. So you're finding what?
The y-intercept.
Finding intercepts. If you find both intercepts, you can plot them and then connect them. You only need 2 points for a line, right? Normally you do a 3rd point just to make sure they all line up. But what if you make a mistake on the 3rd point? Then you're like, which one's wrong? I don't know. So here you can either find the intercepts, or what can you do instead?
You put it in the y equals.
I love it. Put it into the right form like we just did here.
Y equals mx plus 3.
Exactly. Or solve for y. And that's kind of weird. I think part of the thing here is people really are like, why, just solving for y, everything falls into place. Well, don't be freaked out. Just go, oh, good. We built it like that. That's how we built it. So if I solve for y, everything falls into place. I know all this stuff about it without having to do any more work. So let's do both ways. So like we just said, how do I find the x-intercept? What would I do? Set y equal to 0. So I get 3x minus 4 times 0. Now the mistake I always see is somehow that 4 stays alive. I'm not sure how to do that. Wow. Didn't mean to do that. Somehow on the next level, people always have that minus 4 still there. How can that be? It's being multiplied by 0. It's gone. In fact, you really could just do this. To find the x-intercept, do this. Solve that, right? If you're going to plug a 0 in there, it's gone.
Yeah.
Find the y-intercept, do that. Right? So this part dies. You get 3x is 24.
Equals 8.
And I'm going to purposely do something so I can show you another mistake that's made very often. I'm already doing it. There's the x is 8. Now, to find the y-intercept, what do you set? What to what? X equal to 0. So I get 3 times 0 is 0. I get negative 4y is 24. Yeah, good. Divide by negative 4. Now the mistake the mistake I make all the time, and the mistake I see all the time is somebody will plot the point 8, negative 6, and then they'll stare at it. Because you got 1 point then, and in fact that's not a good point, is it? Do you guys see 8, negative 6? They'll plot it and they'll just kind of throw a line on top of it. I can't, with 1 point, how do I know where it's going? 2 points give me direction, right? So I do have 2 points. This is why I was being anal earlier. What point does this represent? 8, 0. X is 8 when y is 0. And over there, y is negative 6 when x is 0. So I do have 2 points. So of course just be careful about that.
Can you repeat it?
Second?
Can you repeat it?
Repeat.
Always, I don't understand.
All of it, okay. Yes, this is definitely from that.
Leave it like this, just. You don't have to erase it.
All right.
She wants to understand the functions.
So this is a general concept about actually any function that I have. If I want to know an intercept, I make the other variable 0. Why does that make sense? Because what happens at the x-intercept no matter what? Did I go up or down any? I don't want to go up or down any, right? And what variable controls up and down? That's the y. So if I want to find the x-intercept, I make y equal to 0. Then I'm on the x-axis somewhere, right? I haven't gone up or down from it. And of course, vice versa for the y-intercept. I make x 0. So never forget that. It seems that people always get a problem where they find the intercepts and they do all this weird crap. Just make the other variable 0 to find that guy's intercept. So when I have this, to find the x-intercept, I make the y 0. I'm forcing the problem. Again, my math is so violent, but I'm forcing this problem to give me information. So tell me where the x-intercept is. No. Then I throw a 0 and his y is like putting a gun inside of me. Throw 0 in there, and I'm forcing it to tell me what the x is when y is 0, when I'm not up or down at all. I'm forcing it to tell me where I am on the x-axis. So that's when I put 0 in there. 4 times 0 is 0. So now I just solved this, right? Divided by 3. That's where the 8 came from. So again, make a point out of it, though. X is 8 when y is 0. 8, 0. Do the same thing for the y-intercept. Make x 0. So this piece, 3 times 0 is 0. Good. Okay, cool. I like that. So please don't let me bulldoze you, right? Definitely stop me if I'm doing something that you don't quite get. Because if you have a question, at least 10 other people have the same question, is my experience. And you'll be their hero for speaking up. All right, so far so good? Yeah?
Do we have to write all that out, like on tests and quizzes?
Show me, you don't have to show me every single step, but show me something. And 2 reasons for that. Number 1 is because, like I said earlier, sometimes these answers come from other places.
So I can like put like a cross, basically, have x, y, have
sure,
0
sure.
here and 0 here, and
okay,
be fine?
Yeah, but show me somewhere, because the other thing is if you get it wrong and you showed me no work, I can't give you any partial credit, because I don't know what went wrong. If you show me some work and it's like a simple little thing, like you said 2 plus 3 is 6, which we all do at some point, right? We just don't, then that's like not a big deal. I grade a lot heavier on concept than I do on little mistakes like that.
Okay.
So if you don't show me any work, I have to assume the worst. You lose more points. So show me work so I can give partial credit. Let's see. So if I were to graph this bad boy, need kind of a big graph here. So I get A0, 1, 2, 3, 8. Yay. See.
Minus.
So there's negative 6, 0, negative 6, 8, 0. So there's my line here, right? What's the slope of this going to be? How can I get the slope from a graph here?
3, 4.
I go up how much?
3.
Well, okay, I go up 3. But just go on the big step. I go up 6 over 8. So 6 over 8, 3, 4. So whenever a slope reduces, that means you could have taken, like you're saying, 1, 2, 3, and then over 4, and that's still there on the graph, right? Little intermediate step. Or I could go up 30 over 40. You see, or I could go up 3/4 over 1. Right, so anything that this ratio equals, that's how much you can go up and over. It'll take you back to the trail, back to the line. So what if I did it this way? How do you solve that for y?
I got the y by itself.
Cool. So how do you do that? What do you do?
I added 4y to both sides.
I like that actually because then you keep it positive.
And I subtracted 24 from both sides.
I like it. And then,
Divided everything by 4. Show the y. And reduce the 24 to
now what do you see there that we knew doing it the other way? Two things. I see the 3/4 slope. And I also see the -6 y-intercept. Right? I don't see this, but I don't need another point. I got a point and a direction. That's all I need for a line, right? So if I were to plot -6, there it is, and then go up 3 over 4, of course, that's the same stupid line, right? So that's why either way will work. If I'm not specific, if I just say graph these, as long as you show me what you're doing, you can do it either of those two ways. Yeah.
What happens if the question, sometimes you get a compound question, like where you have to figure out that, and then it'll say, where does this line cross the x-axis?
Oh, well that, I think you're thinking about where you have to come up with the equation of a line, and then you can start answering questions about it from there. This one I gave you the equation of the line. So the nice thing is if I want to know where across the x-axis, I just got to find the x-intercept, right?
Yeah.
I think you're trying to think ahead to the problems like find the equation of the line that is parallel to this line going through this point, and then it says now find where across, that kind of problem. You guys remember that kind of problem? The equation of the line that's perpendicular to this line, and it goes through this point. Find the equation. Remember those problems?
Not doing those,
Oh, hell yeah.
Oh.
Math repeats itself.
Hey, Jeff,
Yeah.
I did that too, but I got y equals -3/4
Oh,
plus 6. That's the same thing.
You got to be
right?
careful then.
But if you were to switch it over on the other side.
If you do this, don't forget that negative comes with it, right?
Yeah, that's what I did.
And then when you divide by -4, it should cancel that negative there.
Yeah, yeah.
So you should still end up with positive 3/4 x minus 6. You still end up with the same thing.
Okay.
Cool.
I got you.
But I like the fact, the reason that was a nice idea to add the 4y, which is what I do, is it just keeps the y positive from the beginning, so you don't make a negative mistake later. But again, it doesn't matter which way you do it. Okay. How are you guys doing so far? I hope you're picking up on two things. Show me the work, right? And I'm very flexible on the ways you do things, as long as I can see what you're doing. The bad part about math, the reason that people hate math is because they have an early teacher who is inflexible. So you're there going, oh, I got it right, I think I understand this, and the teacher says, no, you did it wrong, because you didn't do it his way or her way. And they're like, I don't understand this shit, I give up on it. I'm just going to be an English major. If that happens anywhere early on, you're kind of turned off the math totally. It sucks. Because we need people to give us better ways to do problems. Every day there's stuff we do now that somebody's going to come up and say, well, this is a better way to do it. And we all go, oh shit, yeah it is, let's start teaching it that way. Right? I don't know the best way to do everything. That's why we need more people that understand and go, well, there's a better way to do this. Oh, sweet. Let's do it that way. Right? A lot of the ways I teach, like in factoring, a lot of the ways I teach, I picked up from students. I look at something like, you're doing, that's a neat thing you're doing. I'm going to start teaching it that way. It's steel.
Why you put 6 over 8?
Oh, how do you get the slope from a graph? Slope is rise over run, right? So how much, from this point to that point, how much did I rise? 6. How much did I run? 8. Rise over run.
Okay.
So I like that you asked that. What's the slope for this here? I don't know, Jeff. Okay. All right, can you guys see that?